Hi, I'm Dr. B. Ravi Kumar, Associate Professor, Department of History, Institute of Aeronautical Engineering. Today I'm going to explain the problems regarding to decoder and encoder, which are there in Module 3, Module 4. In this decoder and encoder, we know that simple like operation of the basic decoder, the simplest decoder which we used is 2 to 4 decoder. This 2 to 4 decoder has 2 inputs and 4 outputs. Basically, a generalized decoder having m number of inputs, n number of inputs, m number of outputs. So the representation of the decoder is n by 2 power m outputs, where n is the number of inputs, 2 power m is the number of outputs. So you can substitute n is equal to 1, you will get 1 by 2 decoder. If n is equal to 2 by 4 decoder, 3 by 3 to 8 decoder, 4 by 16 decoders. Likewise, we can have many number of different types of decoders. So the main purpose of this decoder is to convert that n number of inputs to 2 power m combinations of outputs. So in practical electronic communication subject, we use this kind of encoder and decoders used in communication applications. So in the time of conversion of that binary data into some decimal or octal numbers, and sometimes that decimal number, like decimal voltage of a signal, can be converted to binary information, over which we can following which we can transmit those binary information into channel. So this kind of applications that the decoder and the encoder has. So these two inputs, for example, AB are the inputs, and D3, D2, D0, D1, D2, D3. The truth table for this decoder, for example, AB, D3, D2, D0, D1, D0. If A00, the decoder makes that the corresponding decimal number, is 00. That output is only active, remaining will be 0. At a time, only one output is active. If it is 01 among 4 combinations, the corresponding decimal number is D1 is active, remaining all outputs gets 0. 10, only that D2 is active high, the remaining 3 bits active low. 11 is given that D3 is high, remaining all are zeros. Suppose, what if this we use the external control signals like enable, that enable signals. So if you use the enable signal, if enable is 0, there are 2 different ways to provide enables: active low and active high. I am using that active high. Enable is 0, irrespective of AB, your output will be 0, 0, 0. If enable is 1, it follows the truth table. Okay, 0, 0, D0 is output high, D01, D1 is high, and enable is 1, 1, 0, D2 is high, enable is 1, 1, 1, D3 is high. If you observe here, in all cases among 4 combinations of inputs AB, 0, 0, 0, 1, 1, 0, 1, 1, at a time one output is high. That represents that, it is only high its corresponding input combination 0, 0, 0 minter. So that's why we can take that directly, that D0 is, by the inspection, we can directly take the Boolean function for D0 is A bar, B bar, because A is equal to 0, B is equal to 0. D1 is A bar B. D2 is A B bar. D3 is A B. By using this, we can take that it is like a minterm 0. It is like minterm 0. We can represent it by minterm 0. It is minterm 1, minterm 2, minterm 3. So this representation, like in the decoder, the output is at a time, one output is high, so which is represented to corresponding its minterm of input combination, so that we can use this kind of behavior of the decoder used to implement a Boolean function with the help of decoder. Okay. So basically, if you take any Boolean function, when used any Boolean function, the Boolean function is nothing but summation of minterms. Okay, the minterms. So already decoder output represents that minterms of a given input combination. So when we summing together, so when we adding with the OR gates, then you will get a appropriate Boolean function, whatever you want. So that's why just now, to begin with this concept, or to begin with this, I'll explain the problems regarding to decoder. Implement the Boolean function, implement the specific combination circuits with the help of decoder. In addition to that, we can implement the higher order decoder with the help of lower order decoders. And moreover, we can connect these decoders in communication applications. Let us see one by one. This is the problem. Implement a full ladder circuit with the decoder and 2 OR gates. As I told you earlier, that if you take any Boolean function, it is made with it is a Boolean function, nothing but summation of minterms. That summation can be represented by the logic gates as OR gate. That minterms already available. Minterms are nothing but the outputs of decoder. So implement a full ladder circuit. We know that if you take the full ladder circuit with the help of a Boolean function or with the help of truth table, we can directly take this diagram. If you see this truth table, A, B, C inputs, for example, A, B, C inputs 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1 is the combinations of input. Sum and carry is the output. Sum 0, carry 0, sum 1, carry 0, sum 1, carry 0, 1, 0 plus 1, 1 plus 1, like 0, 1, 0, 1, 0, 0, 1, 0, 1, 1, 1. So, if you find out the Boolean function for sum with the help of K-map, with the help of by inspecting. So, what are the combinations of input after decimal numbers of what are the combinations of input that corresponding output is high? That 0, 0, 1 means 1, 1, 2, 4, 7. This is the minterm representation of sum. C is equal to summation of 3, 5, 6, 7. 3, 5, 6, 7. If you have a minterms, take those minterms and summing together with the help of OR gate, you will get corresponding output. So here it is required, full ladder requires 3 input and 2 outputs. So we have 2 OR gates. To combining those minterms 1, 2, 4, 7, 1 OR gate is required to combine 3, 5, 6, 7 with the other OR gate. So this is the 3 to 8 decoder. 3 inputs A, B, C. You will get 8 combinations of output, 8 decimal numbers, octal numbers 0 to 7. Okay. So each decoder output is nothing but one minterm. I already told you. So 0 means A bar, B bar, C bar. 1 means A bar, B bar, C, like that. So 0 to 7 minterms are there in the decoder output. By combining those corresponding minterms which are there in the sum expression 1, 2, 4, 7 with the OR gate, summing together you will get yes. And if you combining 3, 3, 5, 6, 7, you will combining with OR gate, you will get C. So if I am giving 1, 1, 1, you know that one of the at a time one minterm is active high or one output is active high, that is 7, that is 1, remaining all are zeros. So in all of zeros, when OR gate, this all 4 is 0 means S0. This one input is in high in the OR gate below, you get C1. So in the 7, sorry, in 1, 1, 1 means you will get 1, 7 is also here, so 1 is there, you get sum 1, carry 1. Like that you will get output. So with the help of those concept of minterms for each and every output in the decoder is minterm. So when we summing together, we will get a Boolean function, a canonical Boolean function, so that we can implement a minterms, like we can implement a Boolean function with a small number of minterms. If it is the number of minterms, the expression was with a large number of minterms, then this decoder is not preferred. In that case, if for example 8 outputs, your minterm having an expression with 6 outputs, 6 outputs are there in the minterms in the Boolean function. Out of 8 outputs in the 3 to 8 decoder, 6 minterms are there in the Boolean function. Then in this case, so like the 2 power n by 2 greater than or equal to 2 power n by 2, combinations of minterms are there presented in the Boolean function. Then you have to implement that Boolean function with the help of decoder. Rather than take that 8 outputs connected in OR gate, you just take the 2 outputs connected in OR gate, then take that F bar like output. So you can take that NOR gate of remaining 2 outputs connected to NOR gate, then you will get the same output. You prefer in that way. This is one thing. And the second way of asking questions in examination, design 4 by 16 decoder constructed with 3 to 8 decoder. This also comes under higher order decoder with the help of lower order decoder. Take the 3 by 8 decoder, 3 to 8 decoder. So I am taking 3 to 8 decoder. So if I take the 4 by 16 using 3 by 8, so take this number 16 by 8, you will get 2. That means 2 gates are required. So again, 3 to 8 decoders are required. Take the 3 to 8 decoder, and especially it is enabled decoder, high to high enabled decoder. These 2 decoder and 3 inputs take common for both decoders, X, Y, Z, and take the same X, same Y, and same Z. And the fourth input, that fourth input is connected to enable. Inverter is connected to above, and direct connection is given to below. So in this way we can connect the 4 by, this is 4 inputs, and D0 to D7 and this D8 to D15 outputs. So 4 by 16 decoder. If I take the W is 0, if I am taking W is equal to 0, that 0 makes this inverter 1, so that the above decoder is enabled. If it is W is equal to 1, below decoder is enabled. Let us check with 2 possibilities. For example, 0, 0, 0, 0, W, X, Y, Z. So when W is equal to 0 and X, Y, Z is also 0. So in this case, which one is chip is on now? That 0 passes the inverter, then 1 is available here. Then the above encoder gets on, enabled to this above inverter encoder. This is directly given to 0, this is disabled. So when it is enabled, Then the XYZ combination is 0, 0, 0. That means D0 output is active high. So D0 output is D0 is equal to 1. So what is our combination is 0, 0, 0, 0. X, Y, Z, W. 0 means D0 output is 1. Remaining all are zeros. What if 4 ones? In 4 ones, X, Y, Z, W is 1. When W is 1, this is 0, this is 1, this is active, and a triple 1 pass to both decoder. This triple 1 in the below active decoder means D15, the last highest MSB bit D15. So in this way we can connect the 4x16 decoder construct with the 3x2 decoder. Implement one more example of higher order decoder using lower order decoder. Like implement a 4x16 decoder using 2x4 decoder. So 16 decoder divided by 16 by 4, you will get a 4, and again that take that 4 divided by 4, you will get 1, so that you will get 5. Require 5 decoders. Let us arrange those 5 decoders. First take these 4 decoders. These 4 decoder outputs are, this one is 0 to D0 to D3, D4, 5, 6, 7. This decoder D8 to 8, 9, 10, 11, 12 to 15. And here the 2 inputs, like among, actually it has 2 inputs. Each decoder has 2 inputs. It is a 2x4 decoder. Call these 2 names as CD. Otherwise you can connect common. You can take these as CD. No, it's more worthy to draw this way only. Okay, now CD, 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 and it is enable decoder. Decoder, it has enable inputs. That input is connected to 5th decoder. This enable is equal to 1. You can take directly 2 inputs AB, CD. So this output of first decoder is connected to enable inputs. So that we will make A, B, C, D are the inputs, and D0 to D15 are the outputs. So 4x16 decoder we can design. So what we design that with the A, B, C, D is the inputs, and then D0 to D15 are the outputs. Let us check with one combination 1 0 1 0 A, B, C, D. So when I am taking 1 0 and seed is equal to 1 0. So if it is enabled high, 1 0 means we can take third path 0 0 0 1 1 0 like D0, D1, D2, D3. D2 is enabled. D2 is high, remaining all are zeros. When it is high, I am taking bone line. This chip is on, this decoder is on. When this decoder is on, what is CD? CD is 1 0. 1 0 means again in this case third line in the D0 to D11, that means D10. So among D8 to D11, third one is D10. So D10 is the output. So only D10 is equal to 1, remaining all are zeros. So its corresponding decimal number also D10. In this way, the decoder make the higher order decoder with the help of lower order decoder. And if we come to encoder, we know that just opposite operation of the decoder. Encoder represented by 2 power n inputs and m outputs. And examples of if you substitute n is equal to 1, 2 by 1, the encoder, 4 by 2, and 8 by 3, like that we have encoders. In this case, this 8, 4, 2 represents the decimal numbers. For example, 8 by 4 and 16 by 4, it is hexa to binary, and octal number to binary. So basically, this kind of encoder used in communication. For example, it is a communication channel. It is like a source transmitter, and then it is a receiver. In the before just sending through the binary information to the channel, it is required to convert that decimal number of voltage. For example, your voice signal or video signal, whatever it is, that AC signal must be converted to DC. Before going to apply the DC, okay, like AC2, like analog signal to digital signal, that analog signal must be converted to digital signal, which must be passing through this. One of the circuit is encoder. That encoder is all the analog signal or analog amplitude voltages are discretized into like some levels like 0, 1, 2, 3, like 1, 2, 1 again. So these number of decimal numbers, okay. So if you piece into this signal into sampling, and then that amplitude of sample voltage is represented by decimal, that decimal signal variation of the samples again giving to encoder, this corresponding decimal number of the samples are converted into series of binary bits. For example, it is 1, it is 2, like it is 4, it is 2, it is 1. So 1, 4, 2, 1, that one corresponding 3-bit representation. For example, octal encoder having 3 to 8 conversion or 8 to 3 conversion. This one is represented by 3 bits, nothing but 0, 0, 1, followed by next 4 is converted to 1, 0, 0, next 2 is converted to 1, 0, 1, 0, next 1 is converted to 0, 0, 1. This is a series of binary information conversion of this decimal numbers of samples by the encoder, and then this binary is given to channel, passing through the channel, and then reach to receiver. At the receiver again, whatever the received 3-bit of representation of binary information can be converted back with the help of decoder. There we used 3 to 8 decoder. How we used 8 by 3 encoder at the time at the place of transmitter. So same thing, we use 3 to 8 decoder to convert back the decimal numbers, and then we can following which we can convert that decimal samples to analog signal. So this is most important digital circuit blocks which are used in analog to digital conversion in the communication. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.